Today, we are going to tackle iptables, the super powerful built-in firewall for Linux. I know, it can seem really complex, but trust me, by the end of this, you're going to understand its logical blueprint and you'll be ready to write your own rules. So let's just dive right in.
So let's start with a big question. Just think about it for a second. Your computer is constantly in this whirlwind of digital packets flying in and out. How on earth does an operating system like Linux manage to inspect and control every single one of them without just grinding to a halt? Well, the answer is that it uses a very, very structured gatekeeper. The best way to think about iptables is like a super methodical bouncer at your system's front door. This bouncer doesn't just make random decisions, nope. It follows a very precise set of instructions to decide what gets in, what goes out, and what's allowed to just pass on through. And this brings us to the core of how it's all organized. Seriously, everything iptables does is built on just three fundamental concepts. They're arranged in this clean hierarchy, and once you get this structure, all the commands will suddenly start to make perfect sense. Okay, so at the very top level, we have what are called tables. Just think of these as the bouncer's different instruction manuals, right? Each one for a totally different job. The one you'll use most of the time is the filter table. That's kind of the default manual for just general blocking and allowing. But then you have specialized ones like the NAT table, which is dedicated entirely to rewriting network addresses. Now, inside each of those tables, inside each instruction book, are chapters, and these are called chains. A chain is just a specific checkpoint where our bouncer stops the traffic to check the rulebook. The three big ones you need to know in the filter table are input, which is for traffic coming to your machine, output for traffic going from your machine, and forward for any traffic that's just passing through on its way somewhere else. And finally, within each chain, we get to the actual rules. These are the specific line-by-line instructions. Every single rule has two parts: a condition that identifies a packet, like, hey, is this a TCP packet for port 22? And then an action to take if it matches, like accept. The firewall zips through these rules in order, and here's the key. The first rule that matches decides everything for that packet.
So there's the blueprint, right? Tables hold chains, and chains hold rules. It's that simple. Now let's see how this whole structure translates into the actual commands you're going to use to manage your firewall.
So there are two main ways you're going to want to look at your rules. The command iptables_lv gives you this nice, clean, human-readable table. It's perfect for just getting a quick overview. But then there's iptables_s. This one outputs the exact command syntax for every rule. This is awesome for backing up your configuration or even scripting your entire firewall setup. One is for your eyes, the other is for your scripts.
Okay, to actually change the rules, you've got a few essential tools or flags in your belt. You'll use T to pick which table or which instruction book you want to edit. Then A lets you append a new rule to the very end of a chain. If the order is important, you can use I to insert a rule at a specific spot, and D to delete it. And if you just want to start over, F flushes all the rules from a chain, wipes it clean. Now for the fun part, the condition side of our rule. How do we tell the firewall exactly what to look for? Well, we use these matching flags. P lets you specify the protocol, like TCP. You can use S for the source IP and D for the destination IP. A really common one is D port, which looks at the destination port. And you can even use I to match which network card it's coming in on. All right, so a packet comes along and it matches all our conditions. Now what? What do we do with it? That's where the J or jump flag comes in. This tells the firewall what action to take. Accept just lets it through. Drop silently throws it away. The sender has no idea it was even blocked. It's like ghosting them. Reject, on the other hand, blocks the packet but sends a little denied message back, which can be really useful for debugging. Okay, theory time is officially over. We've got the blueprint, we've got the commands. Now let's put these pieces together and see how to build a secure, real-world firewall policy, starting with what is absolutely the most important principle. The foundation of any good firewall is a default deny policy. This is huge. It means we tell the firewall to drop all incoming and all forwarded traffic by default. We usually let outgoing traffic be accepted, since that's stuff we're starting ourselves. And this is so crucial because it means if a packet doesn't match a specific allow rule that we create, it gets blocked automatically. Guilty until proven innocent. But wait, a default deny policy creates a new problem, right?
When you go to a website, the website's reply traffic needs a way to get back in. This is where connection tracking comes to the rescue. We add this one absolutely essential rule that tells the firewall, hey, if this incoming packet is part of a conversation that we started, just let it through. Seriously, without this rule, your internet would just not work. So with our secure fortress walls up, we can now start poking very specific, deliberate holes for the services we need. For example, to allow SSH access, we just add a rule to the input chain. It says, if you see a TCP packet and its destination port is 22, accept it. It's simple, it's specific, and it's secure. And remember, this logic works for outgoing traffic too. In this case, we're adding a rule to the output chain. This rule is on the lookout for any TCP traffic that's trying to go to a specific destination IP on port 443, which is HTTPS. And if it sees it, it tells the firewall to reject it. It's a really simple way to block your machine from talking to a specific website. All right, let's switch gears for a second and take a quick look at that other instruction book we mentioned way back at the beginning, the NAT table. This is where iptables does something called network address translation. It's this really clever trick that lets all the devices on your home network share one single public IP address. So here's how that works. When a packet leaves your computer, it has its private, internal IP address. Your router uses SourceNAT, or SNAT, to rewrite that source IP and replace it with its own public address before sending it out. Then, when the reply comes back from the internet, the router looks at its notes, performs destination NAT, or DNAT, and rewrites the destination IP back to your computer's private address. That's how the packet finds its way home. So how do you turn this on? You'd think it would be super complicated, but for most home networks, it's literally just this one magic command. In the NAT table, we add a rule to a special chain called post routing for all traffic going out a specific interface, and the action we jump to is masquerade. This is a special target that automatically grabs the current IP address of your router, which is perfect if your ISP gives you a dynamic IP that changes all the time. And that's really it. From those core ideas of tables, chains, and rules, all the way to practical commands for filtering and for NAT, what seems like this huge, complex system is really just simple layers built on top of this powerful, straightforward logic. You now have the blueprint. And that brings us to the final thought here. The real power of iptables isn't about memorizing a bunch of commands. It's about understanding that logical flow of traffic. It's about thinking like the bouncer. So now that you have the blueprint, my question for you is, what is the first rule you are going to write to make your system more secure? Thanks for watching.